Welcome you everybody to this seminar. And Jody, if you can get the slides ready for the end, then I'll need you to help sharing. Um, I'm delighted to introduce to everybody Stephanie Eckman. She is a research fellow here with our SoDa Center and a graduate from the JPSM Ph.D. program. Has worked since then in all sectors, government, academia, industry, in part in Germany, where I'm currently sitting, and is has been a big supporter of the SoDa Center and the activities in Maryland, even now that she works at Amazon. So I'm very excited to have Stephanie present and showcasing to us that survey methodologists and social science researchers at large have a role to play in the new world of AI. And without further ado, Stephanie, I turn it over to you. We'll have ample time at the end of the presentation for question and answers. And most of you, 5 years after the start of the pandemic, know that in these webinars down there, there's a Q&A button, but in case you live on Teams or WebEx, that might be new. So please use that Q&A feature. It collects the question, and then I can either elevate you if you want to ask it yourself. You can notify that and I unmute you and bring you up on stage, or you just type them there and then I'll read the questions out loud to Stephanie. So um, look forward to having this discussion with all of you, but first we'll get some exciting input from Stephanie.
Excellent. Thank you, Frauke, and thank you to the SoDa Center for the invitation to speak today. I have some slides prepared. I'm going to share those. Hopefully I don't have the problems that... Oh, nope, sharing is not turned on. Jody, I've sent a request to share. Okay, and you've already approved it. Thank you. All right, looks like you're seeing the slides. Excellent. Okay. So yes, as I said, I'm very excited to be here today, and I'm going to share some recent work that I've been doing with a research group in Germany and in the US. Frauke is part of that group and some others as well, and I'll talk more about the members towards the end. So as I'm sure you all know, we are seeing a lot of possibilities from AI models, the Gen AI models, LLMs, all the different types of models. We can see both benefits and harms from these models. So in terms of the benefit, we might see increased efficiency. I know my coding and writing has gotten more efficient since I started using these models. And then there's the protein folding approaches that Google has developed that might revolutionize healthcare in the future for all of us, right? So those are the benefits. Of course, there's also some harms. Some of the models can exacerbate issues of discrimination that we see. And of course, they do really just stupid things as well, like tell people to eat glue. So we can see sort of benefits and harms from these models. And whether we get the benefit or the harm, like sort of where we end up on the balance scale here, often comes down to the quality and the data that they are trained on, right? And that's what I'm going to talk about today, is the collection of that training data. And as Frauke said, what I really want to show you is the way that social science, and in particular survey methodology, have a big role to play in collecting that data and making sure it's good enough that we end up on the benefit side of this balance rather than on the harm side. My slides are auto-advancing, which is driving me crazy. So when we collect training data, the first generation of training data was generally for these objective tasks. And the people providing those labels were often crowd workers from Mechanical Turk or more recently Eckman and Scale AI. Sometimes we collected labels from experts, for example, like, is this lesion likely to be a skin cancer or not, right? And very often, especially in the early days, it was just like researchers or graduate students doing their own data labeling. So this is work from like 10 years ago up until about 5 years ago. We really saw this kind of labeling being very popular and common on the platforms. And here's an example of like a task like that. What kind of animal is this? And the labeler should pick, like, is this a dog, a cat, a different animal, or is it not an animal at all? There's no animal in the photo. And so that kind of data collection went on for quite a while and was used to train some of the early um, LLM models. Little attention was paid back then to the design of the data collection instrument or who was doing the labeling. People were just happy to get the data and train the model. And so this is what I'm going to refer to as like the model-centric view, where people were really focused on model training and what's the algorithm and what's the right like hyperparameters to use, and not so much focused on are we really using the right methods to get the labels. More recently, we've seen a turn from that kind of labeling to what's called human feedback. The big models used today, like ChatGPT or the Claude models or some of the Gemini models, right? The ones you probably have on your phone or that you're using while you're coding, they're really trained on everything, on like the full extent of the internet. All the data that the model developers could get their hands on, right, are thrown in there and used as training data. We're no longer like building training data about using graduate students to label photos or tweets or something like that. However, those models trained on everything need some direction to make sure that they are aligned with what humans want them to do, right? And so to do that alignment, that last step of training, it uses a process called reinforcement learning, and it requires this human feedback data. And so here's an example on this slide of what that human feedback data really looks like. Which is the best response to a query? What's the weather like? It's 28 degrees Celsius and humid, or it's a warm, humid 28 degrees Celsius out there. Feels pretty sticky. And so the model needs to learn which of these two responses is the better one and which one it should give. And so again, these kinds of human feedback labels are collected very often from crowd workers, from those platforms I mentioned earlier. And these kinds of feedback are much more of the subjective and opinion type, right? So there's no true answer here. Is it the first or the second response that's better? But the model will learn by getting a lot of different feedback on this type of question. Do people tend to prefer a more conversational approach, like the second response, or do they prefer it to just be more factual, like the first approach? So we collect this kind of data to really make the models fair and safe and aligned, all those nice words. And if we're thinking again about that balance of benefit versus harm, this human feedback data is the one that helps us tilt that model in favor of the benefits. So the core insight driving this work that I've been doing for the last several years, and then I'm going to talk to you today, is that these kinds of questions, what kind of animal is this? And the more recent human feedback type, which response is better? These are essentially surveys. These look to me a lot like web surveys. And when I realized this, I don't know, maybe 5 or so years ago now, I thought that perhaps many of the insights that we have in the survey methods field about how to collect good training data or how to design nice web surveys can make the training data better and thus make the models better. So I'm going to take these ideas from survey methodology and apply them to training data and see if we can improve the models in that way. All right, now it's not working. Here we go. So I'm really picking up here on a switch that's going on in the AI field from this model-centric view to a more data-centric view. So again, the model-centric view says, like, the quality of the data doesn't matter. I can deal with any kind of data because I've got the latest and greatest algorithm, or I'm going to really tune my hyperparameters, right? And so for many years, you saw contests about who could make like the best model on a given data set to make the accuracy or the performance as high as possible. More recently, that approach has somewhat reached an asymptote, and the AI field is now turning to what they're calling data-centric AI. And Andrew Ng, as mentioned here, is one of the real proponents there. And he's got a nice example in this talk that's in the URL here at the bottom of the slide. Let me see if I can turn on my laser pointer. Yeah, so here's a link to this talk where he talks about how a model-centric approach to detecting defects in steel production achieved about a 75% accuracy rate. They tuned that model and made it as strong as they could, and they got to about 75% accuracy. But when they went back into the training data and they said, hey, can we make the training data better without messing around with the model, right? Then they were able to get up to about, what is that, 93 or something percent accuracy. And so Andrew Ng and others have really helped to turn the field from less of a model focus into more of a data focus. And we applaud the interest in increasing the quality of the data. However, I do worry that a lot of people who are involved in the model training are not trained in the science of data collection. Data creation and data collection is a complex task, and it's not always easy to design a good instrument or easy as a labeler to provide high quality data. And so we can bring in insights from psychology and other fields to improve the way we collect this data. So I mentioned quickly the science of data collection. There is a whole science around this topic. Several of you are probably members of these organizations, the International Association of Survey Statisticians, the American Statistical Association, APOR, and others mentioned on this slide. This field has a lot of core textbooks. You can see here in the first column on general topics. There are textbooks specifically around how to write good questions. There are textbooks about sampling, how to select a good sample for a survey, and textbooks about quality in general, and then a series of journals as well. And so I mentioned this to say there's a lot that we can draw on, a lot of decades of high quality research, specifically in the survey field, that we can draw on to inform the collection of training data. And that's the case I hope to make today, that there are lessons in these books and articles and fields that are relevant to the collection of training data for AI models. So when we conduct surveys, we worry mostly about two main sources of error. The first is, are the answers that we're getting the right answers? So we can open our data set, maybe in Excel or in R, and we can look at the numbers that we've collected right there, right? But are those numbers the right ones? Are those the true answers to those questions? That's the first thing we worry about. And the second is like, who responded to our survey? Who did we collect these data from? And are they the right people? Are they sort of representative of the population that we're interested in? I mention this because I think we have exactly parallel concerns when we're thinking about training data for AI models. So when we collect training data, we worry about, are the labels that we're getting correct? And I think we should worry as well about who's doing that labeling and are they representative of the population of interest. So before we go any further, I want to show some example instruments to just, I had some toy examples earlier with a picture of my cat, but I want to show some actual examples of instruments used to collect training data to really ground us in like what's done in the field for real. So here's an example of an invoice. We see the customer name, we see the name of the company up at the top, and then we see a few items and a total, and there's a date, a PO number, things like this, right? So one of the things we might want to train a model to do is pull out the relevant fields here, right? And so here's an instrument. It looks like a lot, right? But there's a lot of information in this invoice. And so you can see here, we're pulling out the name of the company, we're pulling out the date, and so on here. So the labeler should look at this invoice and type in the relevant fields here on the right hand of the screen. So this is an actual instrument used to collect data to train an LLM to extract the information from the invoice on its own, right? Here's another example, a more visual one. And I like this example, first of all, because it's just kind of silly, right? It's a picture of a clay bird holding what my research suggests is an upside down Kazakhstan flag. Here the answer is not so clear, right? Like, is this a bird? Is this not a bird? Or are we unable to tell? I might be unable to tell on this one. So I mentioned this because a lot of the times the things we're asking labelers to do are vague, right? Maybe not quite as silly as this one in most cases, but they are vague and they are things about which people can disagree. And so that's something we have to account for as well when we're designing these data collection instruments. And here's another example. This one comes from OpenAI. This is the instrument that they used to train the Instruct GPT model a few years ago. This one is also a little hard to figure out. Let me walk you through it. So this blue box over here is an article extracted from the internet, and the green box here is a short summary of the article. So the annotator, excuse me, the labeler, I'm going to use those words interchangeably, although I'll try to stick with the labeler. The labeler should read the article in the blue box and then read the summary here in the green box and then indicate the quality of that summary, where 1 is the worst and 7 is the best. So how good is this article summary? And then about the same summary, they answer these, 9 or 8 questions as well. So does the summary fail to follow the correct instruction or task? Yes, no. Is it inappropriate for a customer assistant? Yes, no. And then when the annotator, the labeler is done, they click the submit button up here in the upper left-hand corner. So this is exactly the kind of instrument that was used at least a few years ago to collect that human feedback data that I was talking about, like trying to help the model figure out what is a good response to a given question. Here, the question is like, summarize this article for me, right? And I like this example because, first of all, it's one of the few examples out there. This instrument is really, or this model training and feedback is really well documented, and so I appreciate that. Second of all, I think it's pretty clear that this looks a lot like a web survey, right? We've got a series of questions, maybe grid questions over here. We've got a Likert scale question. So this has many of the elements of a web survey. And third, because I think it's pretty obvious that those of us or those of you who design web surveys for a living can probably find a lot of problems in this instrument, right? This is not like following the principles of web survey design best practices. For one thing, we tend to label our scales with words and not with numbers. For another thing, we don't really like to use these grid questions. They can encourage straight lining. And then my pet peeve is that the submit button is in the upper left-hand corner. That drives me crazy. I'm not sure why they did that. So this is an actual instrument, but it's also one that I think nicely demonstrates where survey methodologists can contribute their expertise and make things better. So let's think about that first question. On the measurement side, are the labels that we're getting correct when we use instruments like these? So the research group that I mentioned earlier, we've done several experiments about different ways to collect these labels. I'm not going to go through all of the experiments and all of the details. I'm going to keep this a little lighter than I often do so that I can get more results in. And because I feel like it's just a lot of details to ask people to take in on a short talk. And thirdly, because when I was at JPSM, my PhD advisor told me that every talk should be an advertisement for the papers. You don't have to give away all the information in the papers. It's an advertisement so that people will go and read the papers. So I'm going to give you some of just the highlights of this research that we've been doing over the last several years into into this question of, are we getting the correct labels, and what are the elements of the data collection process that influence the labels we get. So the first finding here is that the design of the instrument impacts the data that we collect, the training data that we collect. Just as in web surveys, the design of the web survey impacts the data we get in those surveys, we see something very similar here. And so we did an experiment where we collected labels of tweets in 2 different formats. I'm going to call those versions A and B. So in version A, the labelers saw the tweet. I haven't given you an actual tweet here, and then answered 2 questions about it. Does this tweet contain hate speech? Does this tweet contain offensive language? And for each one, they should say yes or no. That's version A. I think it's pretty straightforward. And then in version B, we simply split that into 2 different screens. So one of the principles that people have played around with in the web survey literature is, should we separate, each screen should be its own question, right? So we took that same tweet and just showed it in 2 different questions. First screen, the labeler reads the tweet and answers the hate speech question, yes, no. Then they submit that, they get the same tweet on the next screen, and they get the question about offensive language. So these 2 versions, A and B, are collecting exactly the same amount of information about the same tweet. They're just doing it on slightly different formats. And we see that version A gets lower rates of both offensive language and hate speech than version B. So 52% offensive versus 59 for version B, and then 27 versus 30, a slightly smaller difference on the hate speech. And furthermore, the correlation between those labels isn't very high. So there's only a 65% correlation between the offensive language labels collected in the two versions, and a 60% correlation in the hate speech labels collected. So we're clearly getting different labels when we collect the labels in these different versions of the instrument. But we didn't stop there. We also trained models on each of those versions, right? So we had a bunch of labels collected in version A for some tweets, and then we had the same labels collected in version B. I mean, the same tweets labeled in condition B. And we trained a model on the labels collected in version A and the labels collected in version B, and then we tested them against labels collected in version A and in version B as well. And I'm going to show you some numbers here. These are balanced accuracy numbers, so higher is better. And when we compare the accuracy of these models, we see that the model trained on tweets, trained on labels collected in version B and then tested on labels collected in version B performs much better than those collected in version A. We have an 87% balanced accuracy versus 83 in all of the other conditions. So we're seeing not only do the labels differ by how we design the instrument, but the model is actually performing differently as well. And that's something that I hadn't expected. It wasn't clear that that was going to happen, but that was a nice finding for those of us who know a lot about web servers and how to collect data. And in fact, in this paper, we did not just 2 conditions, we did 5. This is some of the additional detail that I'm trying to not get bogged down by here. But when we look at that same matrix, the 5 different versions of training data and the 5 different versions of test data, we see that the performance, again, the balanced accuracy differs quite a bit across the different cells of this matrix. Version A, that one that I talked about that uses just one screen to collect both versions, doesn't do very well. Doesn't do very well as a training set or as a test set. And version D, which I'm not explaining, also doesn't perform very well. So we see differences in the labels and in how the model performs based on this instrument design issue. We also see a slight order effect. So here we randomize the tweets to orders from 1 to 50, and we see a very slight and negative effect. Tweets asked in the 50th position were about 5 percentage points less likely to be judged to be offensive than those asked in the first position. And in hate speech, the slope here is about 3 percentage points, almost 3 percentage points. So in both cases, we see a decline over the 50 tweets that the labelers were exposed to. So in my opinion, those 2 experiments and some of the other ones that we've done raise the issue of the importance of instrument design. We need to get these instruments correct so that we can capture high quality data to train the models. But some people say like, oh, well, we're not even gonna have people doing this kind of label collection in the future. We're gonna just use the models, and then we'll bring in humans maybe for the really hard ones. We'll have humans verify some of the labels created by the labelers. This approach is called a human AI collaboration, or sometimes a pre-annotation. So it looks like this. Here's a table of admissions data from a corporation's emissions report. And the labeler here, the task is to read that the AI says the 2020 Scope 3 emissions are 533, and then indicate whether that response by the AI is correct or incorrect. This is an approach that a lot of people are excited about because it can reduce the cost and the time needed to label a bunch of things, right? So if you had 100 reports like this, or 1,000 or 1,000,000 that you wanted to extract the emissions data from, using this kind of human AI collaboration approach will reduce the time and the cost needed for all of that labeling. But I think we also have to think about what is the impact on the quality as well, right? And so this is recent work by a recent Ph.D. graduate of Frauke's at LMU, Jakob Beck. So in this example, the annotator or the labeler should indicate whether this data shown underlined here is correct or incorrect. There's one experiment that we did here. For half of the labelers, if they indicated that the value was incorrect, they were asked to enter the correct value. And when we look at the results, We have two really nice results in this paper. The first is that the labelers' attitudes towards AI really predict how accurate they're going to be and whether they're going to correct the AI. So those who have positive attitudes towards AI are less accurate overall and also less likely to correct the AI. Those who have negative attitudes towards AI are have higher accuracy overall and are more likely to correct the AI when it is wrong. And then when we look at that condition shown at the very end of the bottom of the last screen, whether or not the labeler had to provide the correct answer when they said that the AI was incorrect, adding that condition increased the accuracy of the labels achieved, right? So making people give a correction made their responses more accurate, but it also made them much less likely to correct the AI. And we can see the difference between overcorrection and undercorrection in the expected direction here. I think this result nicely fits in with some things that we've seen in surveys as well. Whereas if you make a task more burdensome, people shirk a little bit, right, and are less likely to indicate that they've purchased goods in the consumer expenditure survey. And here we see if we make the task of indicating no, that answer isn't correct more burdensome by requiring people to indicate it, to include a correction, then they're less likely to make corrections. So these findings nicely replicate findings from survey methods and work that Frauke and I and others have done. So these findings are perhaps not too surprising to those of you who come from the survey field. They are known in the fields of psychology and social science broadly, and in the survey field in particular. We know that there are context effects. We know that people satisfied to reduce the cognitive load and even sometimes give incorrect answers to reduce burden. That's what I was just mentioning in the previous slide. And in particular, all of these kinds of behavior are more common when people are answering these kinds of opinion questions that are the hallmark of the human feedback labels that were becoming more and more popular now. So I want to move briefly onto the representation side. We talked about measurement and whether the labels that we're getting are correct. And now I want to talk about who actually does the labels. What we see in the literature and the people who have studied crowd worker populations, that's not work that I've done, but people have, crowd workers tend to come from the global South. They tend to be lower socioeconomic status. In the US, they tend to be mostly women and mostly in the southeast of the United States, at least according to some research that's maybe 5 or 10 years old now. So they're not a representative sample of the entire US or entire world population. In particular, that Instruct GPT instrument that we looked at earlier with the article and the summary, the labelers who did that work were 20% Bangladeshi and 20% Filipino. So 40% of the population of the world does not live in those two countries, right? So we can already see some of the disproportionality there, the way that the global South is overrepresented in the crowd working population. So does it matter if labelers don't represent the world's population or the US population or the relevant population? I mean, it might, right? It depends on a few different things. So this model is adapted from the survey's non-response literature. And I'm repurposing this to show, like, if labeler characteristics such as age or gender or socioeconomic status, or whether you live in the global South or not, influence both your propensity to participate in labeling work, to join a crowd working platform, to participate and give labels for a given project, such as that Instruct GPT labeling. And they also influence the labels that you give, right? Which response do you find to be more helpful? What's the quality of a given summary, right? If these same characteristics influence your propensity to do the labeling and your propensity to give a certain label, then we have an induced correlation between these two, which means that that's not what I want to say, which means that the labels we collect don't represent the population of interest, whether that's the world population or the US population or whatever population we're trying to represent with this model or apply this model to. What can we do about this? We could try to recruit more diverse labelers. We could go after populations that aren't in the global south, or we could go after men, or we could go after people with high SES and try to get them involved in the label collection, right? Trying to sort of break this arm of the diagram here. That's not a bad idea. That might work. That's what we kind of try to do in surveys with incentives, with additional contact attempts, right? But there are some people who probably never want to do this kind of labeling, and some of it's, quite distasteful, like some really hateful tweets and posts, right? We could try to break this arm of the graphic by training people to label in exactly the same way. That is the approach often used in like qualitative studies. If you have several graduate students who are doing like coding, you watch that inter-rater reliability and you try to get everybody to code in the same way. So that's not a bad approach either, but unclear that that's going to scale to this size that we need for the labels for these instruments. So another approach, again, drawing on the survey literature here, is we could use weights to adjust the training data, to collect training data from essentially a non-probability survey, a non-representative survey. Anybody who wants to can come in and do some labeling, and we'll pay them for that. But then we can use statistical weights to adjust that and make the data we get from those people look like a broader population. And so that's the approach that we've taken in a more recent study. I think this is our most recent paper that's been published. And we found nicely that this is simulated labels here. We did not collect actual data here. We just simulated some data. And we found that by varying, so let me back up. We simulated data with two types of labelers. One type was more likely to see offensive language, and one type was less likely to see offensive language. So we're using these tweets again from the first study, but we didn't collect any new data. It's completely like simulated labels, right? So some people see more offensive language and some people see less offensive language. And then we varied the type of those two different, we varied the mix of those two types of labelers. So the x-axis here is showing you how different the two types of labelers are. So 5 means that they're pretty close together. There's only a 5 percentage point difference in how likely they are to see offensive language. Whereas 30 means they're very different. The two types have a 30 percentage point difference in their propensity to see offensive language in a given tweet. And then we varied the mix. So the red line, we've got a nice balance, a 50-50 mix of the two types of labelers. And as we make that mix less balanced in the green line and even less balanced in the blue line, we see that the bias, the performance of the model gets worse. So this is bias. So here higher is worse, right? So the red line is kind of nice and flat. We don't see a lot of difference in bias as we make the two types of labelers different, more and more different. But when we have an unbalanced mix of those two types of labelers, we see the balance increase and then increase again as the balance gets even worse. So this just demonstrates that it actually does matter who labels your data. And again, this is a simulation. This is not strong evidence, but this is what we've got. And I think this is it is a contribution to the literature to show that the mix of labelers impacts the bias in the models. So our approach to fix this problem is to collect labeler characteristics. So if we know that like age and gender are driving the way people label, we can collect that kind of information about our labelers. And then we can calculate weights that make our pool of labelers match the pool in the population, the target population. And then we can use those weights to simply replicate instances. This is a very simplistic approach. We're not doing any sort of statistical weighting here. We're just rounding these weights to the nearest whole number and replicating instances. So labels made by people with really rare characteristics, they'll get high weights, and then we'll replicate their labels many times before we train the models. And when we do that, going back to our toy example, I've added a line here, the purple line adjusted, and you can see that it's nicely on top of the balanced line. So when we use our very simple approach to try to balance the annotators back to a 50-50 mix, we see that the model performs just like it did before we started messing around with the mix of the labelers. Even when the labelers are very different from each other, the balanced and the adjusted models perform pretty similarly. So this is a nice approach and something that's Not finished. We're going to expand on this, but I think a positive sign for the field. So those are all the findings that I wanted to talk to you about today. I'm wrapping up here. I want to say we are trying to get this work out in front of people who collect labels for a living. We have had some success going to the big machine learning conferences. We recently did a workshop in Montreal at one of the big conferences, pulling together the people who are interested in this type of work. However, it's hard to break into like a new field of people who don't necessarily see the value in what you do. So I was very heartened to see this quote by Sam Altman in 2023, where he said that the bias he is most nervous about is the bias of the human feedback raters. And I'm with you, Sam. I don't agree with everything Sam Altman does, but I'm with him on this one. I think we do need to worry a lot about the bias of the human feedback raters on both sides, right? I mean, he didn't get into this detail, but on the measurement side, like, are we getting the right labels and are we getting labels from the right people? I'm really interested in how those of us on the survey science field or in the social science world generally can help the machine learning and AI fields collect high quality training data to aid model development. I'll close with some practical guidance for those of you who are doing label collection based on my many years in the survey field. It's important to recruit many and diverse labelers. I don't think that's the only solution to the issue of representativity that I mentioned at the end, but I do think it's an important piece. The weights are never, even if we get this weighting solution to work, it's never going to work if we don't have like a minimum set of diverse labelers in the first place, right? Part of recruiting a diverse set of labelers is to pay adequately. And then on the instrument side, we should design high quality instruments, make them easy to read and follow. We should test them before we release them. And then we should also be documenting everything for replication and transparency. I mentioned that Instruct GPT example a few times because it is one of the few that really is well documented and easy to find and understand. Not a lot of the other people doing this work are documenting it nearly as well. And we know in the survey field that documentation and transparency is a marker of quality. So as promised, here are the other folks in the research group who are involved with most of the papers that I mentioned earlier: Rabchu, Christoph Kern, Jakob Beck, Bolema, and Frauke Kreuter, of course. Much of the research that I talked about today was joint with these folks. Here is a list of our most recent papers. And here's more information about me. And then I'll just close by saying that the APOR conference is coming up in May. APOR is the American Association for Public Opinion Research. A lot of the work that I mentioned here has been presented or talked about at APOR. This is really the premier conference for people who are interested in data collection. So I encourage everybody to check that out. Frauke and I will be doing a short course, a sort of slightly longer version of this talk at that conference. I believe that will be on the 12th, the day before it starts. And then we're also going to be doing an online course at the University of Maryland in June. Thank you.
Fantastic, Stephanie. Thank you very much. And I keep being technologically challenged now with my camera. Okay, hi. Thank you very much. This was a ton of information, and I should have remembered you talk fast, so it feels like even more information was folded in. We got already quite some questions.
Oh, really?
For those of you who felt the references flew by too quickly, we will share the slide deck and we will share the recordings. So that will be a good way to then see them again and look at the papers. I have a ton of questions lined up here because I rarely do I get the chance to ask you in front of an audience things. So this is fun. But George Stipp beat me to it, and he was wondering if you could say a bit more about weighting the labels and whether you can elaborate if the label distributions are ever parametric or only non-parametric.
Thank you, George, for your question. Thanks for being the first. So this, as I said, is really just beginning work here. Um, the point about weighting the labelers is a good one, and there's a subtle issue here that I haven't quite figured out yet. So when you do this work, you have a lot of labelers, and you have a lot of things you want labeled, right? So in the examples that we've worked with, those are tweets. It doesn't have to be tweets, but let's just use that as the example. And so we've got maybe 1,000 tweets and we've got 100 labelers. And each tweet gets labeled almost certainly by more than one person. So when you're applying the weights, I approach this as we're weighting the labelers. So we're going to take like the age and gender characteristics of the labelers and we'll weight those so that they look like the US population, for example. I'm kind of glossing over the idea of what the population is because that's another thing we haven't quite figured out. Setting that aside, so we can we can create weights to make the labelers look like the population and apply those. But then the tweets can get kind of out of whack. All of a sudden, maybe we've got some tweets that were labeled only by labelers who have really rare characteristics. And now these tweets have really big weights, bigger than the other tweets. And that's not necessarily desirable. And I'm not sure how to handle that. So we kind of really want to adjust the labels, the labelers to look like the population while controlling the tweets a bit. And I haven't figured out how to do that. Maybe there's like an entropy balancing solution there. Whether it's parametric or non-parametric, it's not something we've looked into at all. I encourage more work in this area.
Nice. And I saw someone flash his or her hand, but it went so fast that I didn't see who that was. So you can also just type in the Q&A, put me on stage. In the meantime, a question from Sam, again on the references, and again, I will share those afterwards directly to the email list and then later on the website.
Great.
But the second question was, what are, in your experience, some effective arguments that you saw work to convince people that data quality matters more than data quantity? I mean, pointing people to Andrew's YouTube video is one. We just saw you do that. But in sort of conversations, have you found sort of arguments that work?
Yeah, I mean, I think luckily it's not just me or our research group trying to make these points. There's the data-centric movement within the AI field trying to make the point that, hey, it's cheaper and easier to improve the quality of your data than to start trying to develop new algorithms or get more GPUs or something like that to train better models. I mean, that's why I give these talks and why I like to point out like that we improve the accuracy of the model from 83% to 87% by using best practices and splitting the questions up over 2 screens. Or we improve the accuracy of the model by weighting the labelers to look like they should. That's part of how I make those points, Sam, is by giving talks like this and hoping that I'm talking to the right people, going to the ML conferences, right? So not just talking to statisticians and people who collect data for a living, although those are my peeps, but trying to go to some of the conferences where the annotators are. And then, honestly reaching out to people in the annotation business. I've been speaking with some folks at Prolific because they're doing a lot of label collection these days. Trying to get them excited about these ideas as well. It's hard. It's slow going. It's hard work to make the case for your field's importance to people who haven't heard of it.
Yeah, I feel like as electricity gets more expensive and these models bigger, there's certainly an economic argument to be made too, because you can learn more efficiently if you wouldn't need to sift through all the noise, right? So I think we'll see if money talks eventually here. Ferenc had I hope I pronounced that right, had another question on the 8th grade reading level that you mentioned. And the question was, how do you know it's the task is doable on an 8th grade reading level? But also, if one could adaptively assign raters to tasks that require higher reading levels, and different knowledge. And I guess I can add to that the question on, do you think it's useful to assign, experts to the task?
Mhm. Yeah, those are all great ideas. Oh, I see. The eighth grade reading level is just a guideline. This is something that comes up quite a bit in surveys. It's something that I've always tried to do is when I'm writing surveys or editing survey questions is to get them to an eighth grade reading level. And I'm always telling my clients, not because I don't think our respondents are smart or don't have like higher than an eighth grade eighth grade education, right? But like everybody likes things that are easy to understand, right? It's not a good idea to make people work harder than they want to. Um, so it's just a guideline. Certainly, sometimes some tasks cannot be done at an eighth grade level, of course. The second part of the question was about adaptation. So if somebody's showing that they're doing a good job at the eighth grade reading level, could you try them at the 10th grade reading level and give them some higher or harder tasks as well? Yes, definitely. That kind of thing has been done in the literature. I haven't looked at that recently, but that's something you certainly could do. A lot of people, what I've seen in the literature is people building in things to label where we have a pretty good sense of what the right answer is. And so you might do that in the first few to make sure people understand the task. And then again, every 20th or every 100th as the task goes on to make sure they're still paying attention. So you could certainly do something like that as people are kind of ratchet people up to more and more difficult things to label and make sure that they're continue to pass these more and more difficult sort of planted examples as well.
And what about the experts or the self-perceived expertness? Would it make sense to put that in as
Yeah, I mean,
a
certainly some
criteria?
things have to be done by experts. So, like, I mean, I mentioned this, I think, in the very beginning. Like, if you're trying to figure out about skin cancer or breast cancer or something like that, it's like these kind of medical tasks obviously have to be done by people who are trained. Um, or even just like reading those emissions reports, right? I mean, there's a little bit of training that has to go into that. I don't know anything about emissions and that kind of stuff, right? You have to be sort of taught how to do those kinds of things. So certainly some tasks require expertise. Um, yeah.
Okay. Um, we have another question from Patrick, wondering if you can provide additional insights about the range of adequate pay
Mm,
for these labelers, right? So the concern being that if you pay them too well, you might attract scammers to the various platforms. And if you don't pay them well, then that could affect the
for
task
sure.
quality, right? And so, what, what is your observation from these various platforms, how they square that circle?
Well, thank you for attending, Patrick. When Patrick and I worked at RTI together, he was the one running a lot of these MTurk studies, so he really knows what he's talking about there. So I would honestly go to Patrick for questions about MTurk, and but I think you're totally right. There's the pay effect could go either way here, sort of like a backward bending supply curve of labor in terms of quality. Um, Paying too much could attract people who just want to get in, get some money, and get out and not provide quality data. I mean, obviously, it intersects with the expertise issue we were just talking about as well. If you really are getting data from people who are experts, you have to pay them more as well. And when I was just up in Montreal at the conference, I saw a company that specializes in PhDs who do labeling work in their field of expertise. So that's an interesting approach of trying to hire experts there. Um, the only ones I've worked with are Mechanical Turk, and only with Patrick's involvement, I believe, and Prolific. When we worked with Prolific, um, they have a minimum. You have to pay the federal minimum wage when you're working with them, and so you estimate how much time the task is going to take. You come up with a pay rate that should get them to that minimum wage, and then if the time ends up being longer, you have to go back and pay them extra. So I like that approach. Um, I don't expect that I just don't know enough to know if there's like different quality differences between the panels because I don't have enough experience.
And thanks, Stas, for taking the conversation in parallel online, I mean, in the chat,
Mhm.
reminding us that the adaptive testing is pretty common in the education testing literature and practice when the adaptive exams. And I think that is a good
Yep.
point that one could structure it that way. I I wanted to add to the new discovered company comment that you made in Montreal. Is there, in your opinion, room for labeling companies in that space? Is that something like, let's say, assume because of survey bots, non-probability panels become less happy, less
Mhm.
popular, maybe one could move towards getting into the business of grading or turning these non-prop panels into labeling
Right,
shops. Is that
right.
something that you've thought about?
Sure, yeah. I mean that, and I think that's some of that is going on at Prolific. I'm not super involved with Prolific, but I believe, they started as a place for people, for researchers to field surveys. And they've noticed over the last few years that people are more and more interested in doing labeling work with their members as well. Um, so I think some of that is happening. It can be tricky though, right? I mean, I'm seeing Stas's name here. So like, let's think about Amerispeak. I haven't worked at NORC for a long time, and I'm not speaking on their behalf at all. But I imagine the NORC has spent a lot of time and money recruiting a representative sample of people across America to be part of the Amerispeak panel. Um, if they then started asking those folks to do labeling work, some of which, as I said, can be really tough to see and do, and requires a lot of training, that could be like that could decrease the size of the panel. People could leave for that reason, right? So maybe you want to start a second panel of people who are recruited specifically to do labeling work. Would you still be able to get the same representativeness on that kind of for that kind of panel? I don't know. I don't know. That's an open question. I mean, I would love to see it from a researcher standpoint. I think it would be great if there were such a representative panel for people to do labeling, especially the human feedback labeling for these models. I'm not aware of a high quality panel like that, but it may be that I'm just not aware. So if other people are, let me know. I think there's challenges and trade-offs.
For sure. Yeah. Thank you. All right. I think we have room for one more question if someone wants to come on stage. And there's another question here on time. I attended an AI conference, Sam writes, last week where I spoke to a vendor who was selling services to create survey data using Gen AI. So instead of doing a survey, you could pay them $1,000 to get 1,000 respondents to a survey of your choosing. Any thoughts on this?
Yeah, I think there are several startups who are trying to break into this synthetic respondent approach. I've been playing around with it myself, to be honest. I don't think that that synthetic respondents are going to replace um, true respondents anytime soon. Um, we've seen the same kind of thing with like non-probability versus probability data or weighting, like when response rates started to go down when I first entered the field, right, with trying to adjust for non-response. All of these things, approaches can work if we know what the correlates are of the variables we're collecting. So if we're collecting a variable y and we know that the things that really affect y, thinking about that representation diagram I had earlier, are like age and gender and SES, then as long as our sample is diverse on those criteria, we can do a non-probability sample. We can do quota sampling, right? And perhaps that the LLMs are going to fit, and so the synthetic respondents are going to fit into that as well. If we know that age and gender and SES drive responses, then we can prompt the model like, you're a young woman who's in the working class. What do you think about variable Y, right? Um, it may, that approach might work if we have those variables, but the issue is that we often don't know what the variables are that are driving the responses. And without that knowledge, prompting the models to give us responses is probably not going to work, is my sense. And this
Great.
is where social science comes in, right? This is why we
That's
need to
it.
understand who responds to our surveys and who participates and who doesn't.
Yeah, yeah, yeah. Okay. 1 minute to answer how you use very last question here in the chat, which is any advice for national statistical offices? How can they make their data or work more AI ready or friendly?
Yeah, that's a really good question. That's a good question for Frauke, to be honest.
Okay.
Um,
Well, I can say something to that. Stephanie and I have been discussing a lot, like how could we use surveys and existing data, certainly knowing what is representative and that your labelers are unrepresentative is heavily relying on the national statistical offices. And so I do think it's worthwhile engaging in that kind of thinking a lot more to how can these communities make sure they see the values of federal statistical data as benchmarks. Yeah.
Yeah,
Which
and
of
making district
course
data.
is sorry, did you want to add something to
No,
that,
it's fine. Go
Stephanie?
ahead.
No, which of course, and I'm taking a slide off now, is actually a perfect segue to our next seminar, because if we do make these data available for benchmarks, we have a big privacy challenge,
Yeah.
because you obviously wouldn't want to train the model on any raw data or what have you. And so with that, I want to invite everybody here on this panel to a seminar the next SoDa Symposium that we are holding together with the American Statistical Association and Privacy Confidentiality Committee in the celebration of Privacy Week. So the symposium will be entitled Balancing Statistical and Non-Statistical Uses of Federal Data, Privacy, Governance, and Public Trust. And we'll have presenters both from academia and government. So I hope you can join us on January 28th from 2 p.m. to 3:30 p.m. And maybe we'll see Stephanie back there as part of the discussion, and otherwise reach out. The research group that Stephanie introduced, but I also can, I think, speak for Stephanie, are interested in anyone who wants to have thoughts on this or wants to engage. And we will be, I should also announce that, not only holding that short course at APO in May, but we will also work at the same time on an online version of a course of this type to be folded into the Master of Professional Studies program and to the set of electives in the JPSM Master program. So if you know people who would be interested in joining the Master program and have questions about that, Jody Williams is happy to engage with any inquiries about the program. So this said, Stephanie, thank you very much for a very engaging presentation and for making the time today to be here at the SoDa Symposium.
Yeah. Thank you, everybody, for attending. Bye.